Hi, this is Roger from Kanka Labs, and in our today's episode of the M Show, we'll talk about two kind of transformers, an isolation transformer and a variable transformer, also called a Variac. And they are either useful or even mandatory when it comes to repairing or adjusting or taking apart mains connected devices, and there are still some other reasons why every maker should have at least an isolation transformer. So let's start with this one and put the Variac on the side a little bit for a while. And now, what is an isolation transformer? You can guess it from the name. It's simply a one-to-one transformer. The reason why I have built them by my own is they are quite expensive if you buy them commercially, even used ones at eBay. So it's, at least for me, it was cheaper to build one of my own. It doesn't look very nice, but sufficient for me. And you can already guess what's inside. It's a one-to-one transformer. The only other things here applied is a mains switch, double pole, single throw, and just for switching it on. And on the other side, I've connected a multi-outlet power adapter with a separate switch, so that I can switch the device under test that I'm repairing or whatever I'm doing with it with my foot. So there's first of all, there's also a nice feature. As you can read here, we have on the primary side, we have 230 volt input, and we have two secondary windings, both of them 150 volts. So if you parallel the secondary windings, you also have an adapter either for getting 115 volts devices working at 230 volts mains voltage, or the other way around if you interchange input and output. So that's a secondary use, because most of these isolation transformers have two separate windings. If you put them, as I did, in series, then we get a one-to-one transformer. Now, the first reason you should use one of these when working at mains connected devices is simply for safety. You might now say, well, in modern electrical installations, you always have a, what is it called, a ground fault circuit interrupter, or an earth leakage circuit breaker, so that when you accidentally touch the live wire in your circuit with your finger or any part of your body, you get a current to ground, and the ground fault circuit interrupter immediately shuts off mains power. But that's, well, imagine how this is in the lab. You accidentally touch the live wire in your device, which is in your powered device, and you constantly have to run to the fuse box just to reset the ground fault circuit interrupter. So first of all, for safety reasons, and secondary for convenience, it's much better to have such an isolation one-to-one transformer. And so most of us have at least once been bitten by the electrical mains voltage when accidentally touching the live wire. In Germany it's called the phase. And you avoid this simply by having this one-to-one isolation transformer. But there's another reason when this is really useful when it comes to measuring at non-ground potentials. And for this we'll take a piece of paper just to show you what I mean. So imagine you have on the one side your device under test, mains powered, and your oscilloscope is also mains powered, but both devices are connected to Earth, and then you usually have also a connection from circuit ground to Earth in both devices, and that means both devices, even if you don't put a cable between them, they are already connected via the common Earth and their common ground. So whatever you do, if you measure with your oscilloscope any test point in your device under test, you will always measure relative to the ground and earth of your device under test. And many of you have tried just to put the ground cable of the BNC adapter of your oscilloscope connected to a separate point and not to ground, and then your fuse will blow, because if you put, let's say you have a potential of plus 100 volt here, and if you now connect the ground of your oscilloscope to the plus 100 volt, you shorten out the 100 volt via the earth down to ground, and hopefully the fuse of your device under test then blows, and in the worst case you'll destroy your device under test, at least the power supply where you tried to make a relative measurement. So that happens quite often. You just have any voltage, let's say here as in our example plus 100 volt as your reference point, and you just want to see if there's any AC voltage or any other voltage superimposed on your 100 volt reference, and let's say there are a few millivolts above. Well, you cannot measure this relative to ground because the difference is simply too small, and that way that's just a beginner's fault. You try to connect the ground of your oscilloscope probe to your local reference that you want to measure relative to, and you immediately get a short. And the reason is that in many, if not even most, of your available oscilloscopes as well as your device under tests, the grounds are always connected to Earth, and thereby both devices are always the grounds are always connected, and you cannot measure relative to ground because you immediately get a short. Now, how to get away with it? Simple, with an isolation transformer. So let's see how this looks like if we put an isolation transformer, not only for safety measurements between mains power and your device under test, but also to be able to make relative measurements with your still mains connected oscilloscope. So we have no change in the connection of your oscilloscope. Still it is connected to Earth, and thereby the ground of your oscilloscope is also connected to Earth, but we have interrupted the Earth connection from your device under test because we plug the mains power plug directly to the isolation transformer, and thereby the case and ground is not connected to Earth, because we don't plug the power plug directly into the wall outlet, but put this isolation transformer in between. And now it's no problem if we take our oscilloscope probe, we put the oscilloscope ground to the relative voltage that you want to measure relative to, and the center pin of your oscilloscope probe to the test point that you want to measure relative to. So that's a nice feature. Otherwise, you would need a so-called differential probe, which is very expensive. But by this way, using an isolation transformer, you have a double advantage. You can work safely, even inside the device under test. You don't have any live wire, you don't have the face anymore inside. You can't get bitten by mains voltage, and you can make relative measurements on a relative potential, whatever it is. That's just an example, plus 100 volt. And measure with your mains connected oscilloscope relative to any voltage you want to, or any test point or any reference point. So, but there's still one thing that not many people know, and that is that an isolation transformer is not 100% isolating. And that is a topic I will explain in a separate video, that in fact there are currents that can flow even if you have an isolation transformer, that can still flow to Earth on the secondary side of an isolation transformer. But anyway, that will be the content of a separate video. And now let's take a look at what a Variac, a variable transformer, is and what's the main difference. So here's my home built one. You might wonder what material is the case made of. In fact, it's plywood. It was just a test for me because I had access to a laser cutter which could cut the parts of the box here out of I think it's a 5mm or 6mm plywood. You shouldn't do this with plywood, because plywood is not a good material for encasing any mains connected devicing. But it was I had just access in the local fab lab to the laser cutter, and it was just an attempt how far I could get with it. Now, as you can see, don't watch here the two glow lamps here, face OK and face wrong. I will explain that later. Of course, the main purpose of this variable transformer is that you can put a variable voltage to your device. When you might need this is when you are restoring old, for example, tube radios or tube amplifiers. Often the electrolytic capacitors have dried out and should be what's called reformed. That is, that you very slowly rise the voltage up to the desired voltage over a few minutes or even a few hours. So that's one of the purposes. The other is just to find out how a device behaves when it is working with a little bit under or over voltage. As you can see, I can rise the voltage up to 260 volts here. And now let's take a look inside. Let's take off the knob and take off the top cover. And what we can see is not very much, but you might already guess that there is a toroidal transformer below. And I will show you just in a minute a picture of how this works. So this is not a rheostat or not a big potentiometer. In fact, it's a transformer with a brush where you tap off the voltage. And it's a special kind of transformer which is called an auto transformer. And the most important thing that you should know about these variacs or variable transformers is that they have no isolation effect. Also, the secondary side, the outlet, is mains connected, and so you don't get rid of the live wire as we saw in our example with the isolation transformer. So this is nothing that has to do with safety. If you want to work safely when repairing and using a Variac, you should have an isolation transformer in front of the Variac. So you put two transformers in series. First comes the isolation transformer, and the outlet of the isolation transformer goes to the Variac, and that finally goes to your circuit or to your device. And thereby you can have both effects. You have the electrical isolation for safety, and you have the variable voltage just in case you need it. You want to test your device with different voltages, how it behaves, or you want to reform the electrolytic caps in old historical tube radios or anything else. So now you might wonder, well, how is it possible to have a transformer that is not isolating? That's strange. And again, we'll take a look at a piece of paper how this works and how an auto transformer works. So here I've drawn, as you know, a classical transformer. You have a primary side, usually mains connected. One of the two wires is the live wire, and on the secondary side, that is galvanically isolated. You have your secondary voltage. Now, the first trick in a Variac is, you already have seen, it's a toroidal transformer, which means the winding is circularly wound onto the toroidal core. Now imagine you grind off here the isolation of the magnet wire or the enameled copper wire on top, and you put a brush just to tap off the voltage. Then by turning the center knob and moving the brush over the winding, you get the effect that the secondary voltage is variable depending on where the brush is placed on the secondary winding. You get only a part of the whole winding, and so the secondary voltage is variable. So that's the first or the main trick, how you get a variable voltage just by grinding off on a circular on the circularly wound winding, just a part in the middle, using a brush to tap off the voltage, and by turning the knob you have a only a part of the whole of the total winding where you take off your voltage, and that makes it variable. So, but there's now still the question, what is an autotransformer and why is a Variac in fact mains connected and has no isolation effect? So the first step is, if we connect in this case the lower side of the two windings, the first thing becomes clear why the secondary is not galvanically isolated, because we have a direct connection from primary to secondary. Here we have the brush for the variable secondary voltage, And now imagine we make the secondary winding a part of the primary winding, so we don't have separate windings, but then it looks like this. So you might think, well, this is not a transformer. Well, it is. Imagine the primary side is the total winding from here to here, and the secondary winding is just a tap of the primary winding, and this still has the all the effects of a transformer, in this case of a variable transformer concerning the secondary winding, with one exception. We don't have any galvanic isolation because the secondary winding is just a part of the primary winding. Well, this is not obvious at the first look, but you can look it up at Wikipedia under the entry autotransformer. There the whole theory is explained. And now it also becomes clear why it is mandatory to have the live wire of your mains voltage connected on the upper side, and the lower side must be connected to earth. Otherwise, imagine here the secondary goes to your device under test. And now imagine the case of your device under test is also connected to the ground. And now we put the secondary here. And if we now interchange live wire and earth and would have the live wire here, then we would have the what we in Germany call the phase going directly here through this way to the case ground, and then the case would be connected to the live wire. So now you perhaps can understand why it's absolutely mandatory to connect a Variac that is constructed in this way the right way. You must connect the upper side to the live wire, and the common connection, in this case as it is drawn here, the lower side of the toroidal transformer winding, that must be connected to your protective earth. Otherwise you get bitten when touching the case of your device. And well, how can you check this? Well, you might remember that I've put two neon glow lamps on my Variac, on my home constructed Variac. I'll show you at the end again how it looks like, where we had one glow lamp indicating phase OK and the other one phase wrong. Well, how can you do this? That's quite easy. You take the earth connection separate, and now you connect a glow lamp. I think it's the circuit symbol is that way, with a resistor from your upper side directly to earth, and a second glow lamp from the what should be the earth connected lower line, again with a current limiting resistor to earth. And now this one here is in my construction designated as phase OK, and this is phase wrong, because if the Variac is connected the right way, the glow lamp would light up here, because we have a path down to ground, and the phase wrong cannot light up simply because both connections are here at earth. And if we interchange live wire and earth input, then the phase wrong would light up. And so that's a simple trick for safety, how you cannot forget to connect the upper side of the Variac really with the phase, with the live wire. So finally, let's take a look at, again, how this looks like in my home constructed Variac. So here it is again, and you can see the two neon glow lamps, phase OK and phase wrong. Doesn't look nice, and probably some of you will complain about all the construction, but again, for me this is sufficient because I know what I'm doing. But when you ever get hold of a Variac, you should be very well aware that first of all, this is not isolating the mains voltage, and especially it's not isolating the live wire. And second, that you absolutely have to connect it the right way to your mains, because otherwise you have very substantial safety issues. So that was it for today about the use and purpose of isolation transformers, and what Variacs are good for, how they are constructed, how they work, and what you should watch out for. So that was it for today. Thanks for watching. I hope you liked it. Until next time, bye from Roger, bye from Kanka Labs.